Okay, good morning. Welcome to
FamilyMath221a.
221a. So last night I was looking at this old book of ours, and I don't remember why I was even looking at it. I just noticed it, and I thought it'd be fun to do a couple of probability problems.
Yep.
We haven't we spent a lot of time talking about probability and counting this summer, right? It's been a while.
Yeah.
So here's one problem from that book, or based on one from that book. It's probably not, the numbers probably aren't exactly the same. You have three guys who are doing archery.
Yep.
And they shoot at a target. This person hits the target, let's say, 3 out of 5 times. This person hits it 3 out of 4 times, and this person hits it, I don't know, 5 out of 7 times. Okay?
Yep.
So this person hits the target 3 out of 5 times, this person hits it 3 out of 4 times, this person hits it 5 out of 7 times. And the question is, what is the probability that when each of them fires one arrow,
Yep.
that at least one person hits the target? So do you understand the question?
Yep. Yeah.
So they're all firing at this target. This person always hits it 3 out of 5 times, 3 out of 4 times, 5 out of 7 times. They all fire once. What's the probability that at least one hits the target? Ooh,
Well,
interesting.
We could add up the total to the total probability and then divide by 3.
Okay, that would be the average probability of somebody hitting the target.
Yeah. But we need the probability of someone hitting it.
So at least one person hitting the target. Well, let's.
Maybe we could get the least common multiple of 5, 4, and 7.
Okay.
That would be 140.
That'd be 140. So we could understand the probabilities in terms of 140.
You'd see how many times each one hits out of 140 shots.
Okay.
And then we could divide that by 140.
What would that tell us?
Well, it would tell us the probability, I think, of one person hitting it.
By adding up the probabilities and dividing by 3? Or dividing by 140?
Because it's out of one, we're gonna make a common denominator, and then if the common denominator is 140, well, we might need to get to something over 1.
Well, not sure. Not sure. Let's keep brainstorming here.
So we need at least one person to hit the target.
Yeah, we need at least one person to hit the target.
Well, this guy hits the target. This guy hits the target the most often.
Right.
So he has the highest probability of hitting the target.
That's true. Yeah.
What else could we see? They're all firing one arrow.
Yeah.
And
And maybe we could see what's the probability that all 3 of them hit, or just 2 of them hitting, and then 1 of them hitting.
Ah, that could be interesting. The probability of all 3 hitting? Maybe the probability of exactly 2 hitting?
and then maybe 1 hit.
Exactly 1 hitting? Is there another possibility?
Well, none of them hitting.
None of them hitting.
Well,
Okay.
well,
Which of these things satisfy the conditions of the problem?
Well, just this case.
because
Oh wait, no, actually all these 3, because it says at least 1.
At least 1 hits. Okay.
well, this probability is least likely to happen.
That's true. It's least likely to happen, though this may be not too hard to calculate. These ones are going to be harder to calculate.
Well, if we want the probability of 3 of them hitting the target, I think we add up these totals.
Okay, let's go move on to the next movie.